Welcome viewers to this SD online classes. Today we will be doing class 9 MBSC Mizoram Board of School Education chapter 3 of science physics. Okay, this is physics chapter 3. We have finished chapter 2 and in the chapter 3 also we are in the second part, thrust and pressure. Gravitation already done. Now flotation. In flotation we will study thrust and pressure. Let's see what is thrust first. Thrust is the force. Okay, thrust is just a force. Okay, I'll write the definition what it. Let us understand the meaning. The meaning is this: the force applied on a surface. Suppose this paper is this surface, okay, and now I'll apply the force. If I apply the force like this, okay, like this is not thrust. This force is not. The force thrust is this one. Can you see? Perpendicular. Direction perpendicular, or perpendicular also called, another name of perpendicular is normal. If that force is perpendicular, can you see the paper 90 degree? This is called thrust. Okay, very simple. It is a force which is perpendicularly applied. That is called thrust. Fine. For example, how the force is different from thrust is that if you apply the thrust in a perpendicular direction, it has more effect. Can you see? If I put my pen like this, it will hit me more firmly and it will give some pain if I do this. But if it is like this, it will give less pain even with the harder one. So the area in contact, suppose I have another thing, suppose this is having the surface bigger. If I do like this, press it, there is very little pain. But if I change the area and make this area very less, now this will give me more pain. Okay, so that is called pressure. We'll introduce that. We'll write how it is pressure. Okay, after this. So this is the pressure. The thrust per unit area is called pressure. Okay, pressure is force by area. Okay, understand, pressure and force is not same. Pressure is force divided by area. How much area you are applying the force, that will decide your pressure. So in order to study pressure, we first study thrust here. Okay, it's a very simple concept. And now as I have already told you that thrust is nothing but force which is perpendicular, right? Remember this. Okay, so now unit of thrust. So if you remember, I told you that thrust is force, so unit of thrust will be unit of force. Unit of force is what? It is Newton. So now what will be the unit of pressure? Pressure unit you can understand from here, Newton and area. What is that? Newton divided by area means meter square. Area's unit is meter square. It is also called, the same thing can also be called Pascal, PA. PA is Pascal, PASCL. Pascal is the unit of pressure. Okay, so this is how the two things we have studied, that is thrust and the other is pressure. Now the next topic will be pressure in fluids. FLUIDS. What is fluids? Fluids is collectively both gas and liquid is called fluids. Okay, there is solid, you know, but other than solid is what? Gas and liquid. Gas and liquid, if I want to say together, I can say fluids. Okay, what is pressure in terms of fluid? More in the solid we study pressure little less, but more common is gas and liquid. So let us write what is this. Now the pressure in fluids, how to understand. Before that, we again introduce thrust in the case of liquid and gas. Suppose you have a container, maybe a packet or something like that. Inside that you put some gas or liquid, maybe. The force exerted by that fluid, that may be liquid or gas, on any object immersed in it and on the walls of the container. If you are putting it inside a container of water, the water will create some pressure on the wall. Okay, left side, right side, up side, down side, everywhere. In case of gas, up, down, everywhere. Inside a balloon also, you understand, the balloon inside gives outward force to the wall of the balloon. Okay, that is called thrust. So that thrust divided by the area is called pressure. Very easy, same concept like this. And one interesting thing is that in the fluid, the pressure is transmitted everywhere equally. Okay, that is called Pascal's law. That is what we will tell the next here. So Pascal's law is that Pascal's law is what? It says that, very simple, very day-to-day thing, pressure exerted means pressure due to the fluid in any confined means close, confined mass of fluid is transmitted equally in all directions. What is the meaning? Suppose you have one container here, inside there is gas. So Pascal law says that the pressure here, pressure here, pressure here, pressure here, pressure here and pressure here, all is every time same. I cannot show direction to the pressure, remember, because pressure is not a vector quantity. Just for your understanding, this pressure here, everything is, every pressure is, here you calculate, here you calculate, everywhere it will be same inside a closed container, okay, confined conductor. This may be liquid, this may be gas. So this is the rule of Pascal's law, okay, remember this. Now next topic will be buoyancy. So next topic is buoyancy. Here the tendency of a fluid is gas or liquid, remember, to exert. Tendency means its habit, okay, of any liquid or gas has this habit of exerting an upward force on the body when it is completely or partially, fully or some half part is immersed in it. Suppose I have one bucket here, water here. Suppose I keep one stone or anything here, I want to drop it down. You will feel that it is, the force is acting upward, it is repelled back, okay, upside. This is called buoyancy, very simple, okay. It will not go very easily inside, some back force is always there. The tendency of a fluid to exert, this fluid is this one, okay, the habit of this water or the gas to push the stone outside, or it may be paper, it may be a plastic, whatever. If it has that habit, very little habit or very high habit, a high strong tendency of that is called buoyancy, you understand. It will not allow something to go inside very easily. So that habit of pushing it outside, upward force on a body when it is completely means going here, or partially, half outside half inside, in it is called, every time the force is exerted this way, this upward force is called buoyancy, okay. Next is buoyant force. This was habit, okay, this was the habit of the liquid or the gas to push everything outside back is called buoyancy, and the force with which, this force here is called buoyant force. The force with which it is making that up, the resultant upward force, the force is upward force, okay, when you are immersing something inside downward, the force is upside experienced by the body, this is the body, when it is completely or partially immersed in a fluid is called buoyant force, okay. We will try to understand the activity with the help of activity. What is buoyant force? Okay, it is very easy. Suppose you have one bucket here, okay, you have a bucket, you have one bucket here, and suppose here you have water inside, okay, and you have a bottle here. Suppose you have a bottle here and this bottle is like this, okay, and you are pushing this bottle inside. When you push with your hand here, okay, suppose you have your hand here and pushing it with your hand down, what will happen? If you are pushing it with your hand down, you will feel the upward force, very common, you can try at home also. Inside a bucket you try to push a bottle like this and you will force this upward force, okay, upward force. This upward force is called buoyant force, okay, upward force is called buoyant, B-U-O-Y-A-N-T, buoyant force, okay. This is the activity 3.1. you can see in your page number 61 of your textbook, and this is how you can understand what is the meaning of buoyant force, okay. Looking to this diagram, you can understand the formula also. Suppose Fa is the force you have applied, okay, force applied, with which you are applying force in your hand downside here, F, right, for A means applied force, and suppose W is the weight of the bottle. Okay, weight of the bottle. And suppose U is, suppose Fw is the force of water on the bottle upside. Okay, now this is W, weight, force of gravity. Weight is also called force of gravity, because due to force of gravity only everything is having its weight. Okay, now this U I will not write here. This is F A, downward. Upward force has another name, that is F W in the diagram. Okay, fine, F W, I'll give the name like this. And now if you see all the downward force, what is that? F A is downside. Can you see downside? Weight is also downside, W. And what is upside force? F W, that is force on force by the water on the bottle. Okay, now if I do this, F A will be equal to force by the water on the bottle, this F W, minus, it will go this side, W. Okay, now what you can do is the upward force exerted on the bottle is called upthrust. Another name for buoyancy is upthrust, or BUOYANT, buoyant force. Okay, so what is this? It is denoted by U. Okay, so what is this? U is equal to V rho G, volume, density, acceleration due to gravity. So where V is volume of body, that means here the body is bottle, and rho is what? Density of liquid. Here it is maybe water, density of liquid, and G is acceleration due to gravity. Acceleration due to gravity. Okay, so this is that V rho G is your upward force, or you can call it the, what do you call it, the buoyant force or upthrust. Two names are there for the same thing. Okay, so you can understand, we will use this for Archimedes principle also later on. This is just to understand this. Okay, so main basic thing is that anything when you push inside the liquid will create an upthrust force, upward force, that is called upthrust or buoyant force. That much you have to understand from this activity. And this activity also will tell that this force depends on what? This force, you can very easily understand, depends on, number one, size of body. Why it depends? That is why it is V. Size of body means what? Volume will decide how big or how small. Number two, it will be the deciding factor. Another is the density of liquid. Okay, this I will not say because acceleration due to gravity is same everywhere, so don't need to write number 3 G. Okay, size of the body, two things will decide your upthrust. If you push anything inside the liquid, what are the things will decide? First thing is what? The body, how big or how small. Okay, if it is small, easy to go in. Okay, more force will be given by the liquid if the body is big. So this is this one. The second one is density of the liquid. If the density of the liquid is less, very easily the thing will go inside. Otherwise, the upthrust will be more if the liquid is highly dense. So these are the two things about this formula. Okay, thank you.